All right, so to continue on this theme that we talked about in the last couple of classes, we've discussed the monetary system. In particular, we've talked about some of the key functions of money in our economy, the different types of money that we've used historically, differences between commodity monies versus fiat monies. We talked a lot in the last class about the role of the commercial banking system in influencing the supply of money, right? And that is through this process of multiple deposit loan creation, right? When banks practice fractional reserve banking, they can expand the money supply through this multiple deposit loan creation process. And then we also spent a bit of time talking about the central bank of the United States, called the U.S. Federal Reserve, and how it is the responsibility of the Fed to try to, in some ways, manage the supply of money in our economy. And we discussed in some detail about some of the various tools that the Fed has in order to try to manage the money supply. Okay, go back and review those. The most important, I think, are open market operations and things like discount lending and interest paid on banks' reserves, etc. Okay, what I want to do in this particular section, which I believe corresponds to chapter 17 in Mankiw's textbook, is to start to actually develop a more formal model that helps us better understand the relationship between money, or the supply of money, and some of these other key macroeconomic concepts or variables that we've introduced throughout the semester. Importantly, the economy's rate of inflation. Another important one is going to be also interest rates. How does the money supply relate to interest rates in our economy? Now, just as a quick review question, what is inflation? What's the definition of inflation? How do we compute it? You guys remember? How does it differ from the overall level of prices, or the kind of the cost of living? A country's inflation rate measures the growth rate of the general level of prices over time, right? So if the price level kind of tells us what the overall cost of living is, the rate of inflation tells us how quickly those costs are rising on average from one year to the next, right? You really need to know the distinction between prices and inflation at this point in the semester, all right? The model that we're going to try to piece together and use to analyze changes in the money supply relates that to the economy's inflation rate, okay? All right, now before we begin doing that, let me actually exit the slides for just a moment and share with you guys some actual data, historical data on US inflation. Now, we've seen pictures like this at various points throughout the semester, but I think now that we're going to start to look at a more formal model of inflation and the money supply, I think it's important that you guys really have a pretty solid understanding about the historical record of inflation in the United States, okay? Now, in the past few decades, let's say from the early 80s on to the present, we've had, this graph does not look correct to me. Hold on. This would make more sense. Okay, sorry about that. I had the wrong data. Okay, so this is the gross domestic product deflator, measure of inflation. Now, what I wanted to say was that in the past couple of decades, something that we've certainly experienced in this country is fairly low and stable inflation. At least since like the mid 1980s, inflation has kind of hovered around 2% or so. It's been a little bit above that, a little bit below that over time, okay? However, that's not always been the case, okay? It's important for you guys to recognize that the United States has a pretty long history of high and sometimes very volatile inflation, okay? Particularly through the 1950s and 60s and 70s, you see this episode where inflation was pretty volatile after World War II and the Korean War, and then kind of trended up over time, reaching a peak in the late 70s, early 80s of around 11 or 12%. So just because you guys are used to seeing very low and kind of tranquil inflation does not necessarily mean that that's the way it's been in the US over time. Now, if we had more data on the GDP deflator dating back all the way earlier, what you would find is that even before World War II, the behavior of inflation was also extremely volatile, right? There were periods where the inflation rate spiked at double digits, and there were also periods in which inflation was actually negative. Now, on this graph, we see that the only time where we actually experienced deflation was in the early 1950s. But if you look at data from the Great Depression and even earlier during some periods in the 1920s, we also experienced deflation. That is falling prices or negative inflation. And so it's just because we've had pretty low and stable inflation recently does not necessarily mean, or does not mean in fact, that we've always had such good performance on inflation. At some points, inflation's been very high and quite volatile. And at other points, it goes low and even becomes negative or deflation. So the basic goal of this chapter really is to understand the larger economic forces that give rise to these kinds of decade-long trends in the inflation rate, okay? What is it that was really causing something like inflation to persistently rise from 2% to over 10% throughout the 60s and the 70s? What economic forces were responsible for persistently lowering the rate of inflation through the 80s, 90s, and 2000s? We're going to attempt, so basically this presentation, I guess, is going to be divided into two parts, okay? The first thing that I want to try to accomplish today is to understand what actually determines a country's rate of inflation in the long run, okay? And to do that, we're going to develop, or I'm going to introduce you guys to a very well-known theory in macroeconomics called the quantity theory of money. Okay, it was popularized by Milton Friedman. This particular model essentially elaborates on one of those key or 10 big ideas that we sort of glossed over at the very beginning of the semester. In fact, I don't even think I even talked about this one on the first day of class. I just had you guys kind of review it on your own. And that basic idea is that prices in a country tend to rise when the government prints too much money. All right, that's one of the 10 basic principles or big ideas from economics. What the quantity theory of money does is it formalizes that principle. And so we're going to kind of elaborate or expand on that over the next couple of classes. Now, let me just remind you of one thing. This particular model of money that we're going to talk about, the quantity theory of money, really only describes the relationship between money and prices and inflation in the long run, okay? That is, how are these variables related over long periods of time? Not quarters or even years, but like decades at a time, okay? If you guys go on to take intermediate macroeconomics, if you are an econ major, then you will develop and study business cycle models that can explain why inflation fluctuates over shorter periods of time. But the one we're going to discuss today is very much a long-run money model of money. The other thing I want to accomplish in this section, which I won't get to until next week, the next class, is that I want to talk about some ways in which inflation imposes a cost on society, okay? Now, just to kind of foreshadow this a little bit, if you ask the common person off the street why inflation is a bad thing, that person would likely tell you, well, inflation makes stuff more expensive, and so it makes us feel poorer, right? Because it raises the cost of goods and services. Well, that's kind of a common mistake. In the long run, it's true that inflation causes the price of goods and services to rise, but it also tends to cause the prices of labor to go up as well. So our wages go up as well as the prices of other goods and services. So the real value of our wages are not terribly harmed by high inflation, okay? I want to talk about that a little bit, but then go over some clear, kind of distinct reasons why inflation still imposes certain costs on society. There are 4 or 5 that I want to discuss, but again, I won't get to that until Tuesday. Okay, so today we're going to kind of develop the model, and in the next class talk about the social costs of inflation. Okay, questions about that then? All right, so the first thing that we need to do when we're devising this or developing this theory of inflation is to try to look at the relationship between the price level and some concept called the value of money. Okay, now that may seem like an odd thing to say. What do we mean by the value of money? Well, let me just illustrate this with an example, okay? If we were to jump into a time machine and go back in time, let's say to 1990 or say, we might be able to buy a ticket to an Alabama football game. Let's say the face value at the time was maybe $20. So in 1990, you could pay $20 to get into a University of Alabama football game. Now, I confess, I don't go to many football games these days, but can you guys tell me what's the face value of a football ticket now? Surely it's more than $20. Okay, so a lot, $100, $200, whatever. Okay, let's just say for the sake of argument that it's $100 today. Okay, now, one thing that we learned earlier in this semester is that the market price of something is supposed to reflect the true market value of some good or service. Okay, if we see that the price of a football ticket has gone from $20 to, let's say, $100 over time, does that mean that the value, that is our enjoyment of attending an Alabama football game, has gone up 5-fold over those periods? Probably not. Probably the enjoyment we get from attending the game has stayed relatively stable over time. Maybe it's gone up a little bit, but much more likely what has happened here is that the value of the money that we're using to purchase the ticket has actually gone down, okay? That's the way I want you to start thinking about this when we're talking about the connection here between money and inflation. Inflation doesn't reflect so much the costs of goods and services, that is the market value of goods and services, but instead it reflects more the value of the money that we're using to purchase those goods and services with, okay? Now, this easy example here illustrates that we can view the price level in our economy in one of 2 ways, okay? The standard way is that the price level, which I'm going to denote with the variable P, okay? So we can think of that as like the GDP deflator or even the consumer price index, okay? P, the price level, measures the cost of a basket of goods and services measured in terms of dollars, okay? So when the price level rises, we're gonna have to spend more dollars to obtain the same quantity of goods and services. That is the standard view of the price level, right? There is an alternative view that I think is more useful for us here, and that is that when the price level rises, the real value of our money is actually going to decline, right? In other words, a given quantity of our dollars purchases fewer and fewer real goods and services. Now, if P measures the price of some basket of goods in terms of dollars, then what does $1 divided by P dollars reflect? That reflects the value of a single dollar measured in actual real goods and services. So if P is the price level, then the real value of our money is simply measured by the reciprocal, 1 divided by the price level. Let me give you a quick example to illustrate this. Let's suppose that our CPI basket of goods only contains 1 candy bar. That's the item that we consume in our economy. If the price of a candy bar is equal to $2, then what is the value of our money? The value of $1 in our economy is half a candy bar, right? That's the command that $1 has over this real good. What happens if the price level or the price of a candy bar rises to $3? Then what's the value of our money in this exercise? It falls to only 1/3 of a candy bar, right? 1 divided by the price level. What inflation is doing here is it is, of course, driving up the prices of goods and services. But really what it's doing is it's driving down the value of our money. Okay, that's the first thing that principal students need to understand, is that when you hear inflation, you kind of automatically think, okay, stuff is getting more expensive. Try not to think of it in terms of that. Try to think of it in terms of the value of our actual money. That inflation is consistent or implies that the real value of our money is declining over time. Okay, does that make sense? This idea of the value of money is really important to the model that we're going to work through today. Okay, so now that we have established this link between prices and the value of money, we can think about or model inflation using this particular model called the quantity theory of money. Now, in short, the quantity theory asserts that the value of money in our economy is ultimately going to be determined by the supply of money that is actually in circulation. All right, and I think that's pretty straightforward to understand. The value of anything is usually determined by its scarcity, right? Items that are really abundant aren't going to have a high price. The value is not going to be very high, right? But values that are much more scarce, particularly if there's a decent demand for them, the price is going to be a lot higher, okay? Money is really no different. Now, we're going to study this model called the quantity theory from 2 different angles today. All right, let me be clear about this. The first way we're going to look at it is through a basic supply and demand type of framework. So we're going to develop a supply of money, we're going to develop a demand for money, and then we're going to look at what happens in the money market in equilibrium and how that determines the value of money and therefore the price level. That's one kind of classical way of viewing the quantity theory. But we're also going to take another look at it from a different angle using something called the quantity equation directly. So instead of using a supply and demand graph, we're going to use a little bit of math. Now, you don't have to freak out here. The math is extremely easy, all right? It's just one equation, a little bit of algebra, okay, but nothing complicated, all right? Both of these 2 ways of looking or thinking about the quantity theory are going to give us the same answers, all right? So they're kind of 2 sides of the same coin. They should give us identical results, but I want to approach the problem from both aspects. Okay. All right, so let's start with the supply and demand way of examining the quantity theory first. The value of money in equilibrium can be examined through the lens of a supply and demand model, much like the value of any other type of good or asset or commodity, right? We've spent some time this semester developing various supply and demand models. We looked at a supply and demand model of the labor market. We looked at a supply and demand model of the loanable funds market. We've taken a look at the supply and demand of oil markets, right? All of those markets determine the value of whatever the good or asset or commodity was in question. We can apply the same principles, the same concepts to look at the value of money as well. Let's start by looking at the supply of money, okay? Now, this is going to draw on a lot of the discussion that we talked about in the last couple of classes. But what is it or who is it that determines the money supply in our economy? Well, that's actually kind of a complicated question. It turns out that there are three agents or three types of people that determine the money supply, and all are kind of working in concert with one another. Remember what the money, if we think of the money supply in terms of M1, it's basically currency plus checking account deposits, right? So one group of people that affects the money supply is households or consumers, right? When we decide how much of our money to hold in the form of currency, we're going to affect the money supply. But the banking system also impacts the money supply. When banks decide how much they want to of their deposits to hold in reserves and how much they want to loan out to other investors through fractional reserve banking, they're also going to affect the money supply through this money multiplier process. We talked a lot about that in the last class. But then most importantly, there's the central bank or the Federal Reserve, right? The Fed has all of these various policy tools to try to manage the supply of money in circulation. We're going to make an assumption today, and that is that we're going to assume that the Fed or the central bank can precisely control the money supply and set it at whatever desired level it wants. Now, this may already be confusing because the last thing I think I told you from the previous class was that the Fed does not exercise perfect control over the money supply, right? Because it can't perfectly anticipate how consumers in the banking system are going to behave. I want to reverse that today and assume that the Fed can anticipate those actions. So when the Fed adjusts its policy tools, it knows exactly how the money supply process plays out through the banking system. It understands this multiple deposit creation process. Okay, so the money supply in this quantity theory of money is going to be a policy variable for the Fed, our central bank in the model. Okay, now, let me just throw a quick review question at you. What happens to our economy's money supply if the Fed decides to buy bonds in the open market? Conducts an open market purchase of bonds, right? That's one of the Fed's policy tools. What happens to our economy's money supply if it takes that action? Aaron? Sorry? That's right. So the private sector has some portfolio of bonds and money, right? Let's say I'm the Fed and Aaron is the private sector. If I buy bonds from her directly, we're gonna swap bonds for money. And so money gets injected into the private sector, right? The money supply is gonna increase. Though Aaron might spend those dollars on goods and services, which get redeposited back into the banking system and then loaned out to other investors through the money multiplier process, okay? So these open market operations are a key way that the Fed controls the money supply. We're gonna assume that the Fed here has perfect control of the money supply. Okay, how about money demand? Let's talk about that for a few minutes. This is a little bit more complicated. What does money demand refer to? If we think about it, money demand really just comes from people's decisions about how much of their wealth they want to hold in liquid form, right? Remember what wealth is. This is the total stock of our various assets minus our debts, right? What money demand is referring to is more or less a portfolio decision. That is, how much of our wealth, what fraction of our wealth do we want to hold in liquid form versus illiquid form? That's where money demand comes from, okay? How much of our wealth do we want to keep as purely liquid versus illiquid? Now, there's lots of factors that affect that money demand decision, okay? But I would say probably the most important one is the general level of prices, the price level, okay? Now think about the relationship here. What do you think happens to our money demand if the prices of goods and services go up? As P increases, it takes more dollars to buy the same amount of goods and services, right? What we actually care about in the economy is consuming real goods and services. So as the price level rises, we're going to need more money to access that same amount of real goods and services. And so the quantity of money demanded should actually go up as the price level rises. In other words, as prices go up and therefore the value of our money declines, the quantity of money demanded should go up, other things being equal. As our money loses value, let me emphasize this again. I want to make sure everybody understands this. As our money loses value, we need to acquire more of it in order to purchase the same quantity of goods and services that we're used to consuming. So the quantity of money demanded has to go up, other things being equal. Now, what are some of these other factors that might affect money demand outside of the prices of goods and services? I'll name a few. Real incomes, interest rates, the availability of things like ATMs. Well, think about it. If real income goes up, we get richer. As our real incomes rise, we're going to need more money to facilitate a larger number of transactions. So we would expect money demand to increase as our real incomes rise. How about interest rates? Nominal interest rates, that is. What do you think is the relationship between money demand and nominal interest rates? If nominal interest rates go up, what do you expect to happen to your money demand? So money is an asset that earns zero nominal interest. It's a non-interest bearing asset, right? So as interest rates rise, the opportunity cost of holding your wealth in the form of money goes up. You're losing out on the opportunity to save in the form of an asset that earns a higher rate of return. So as nominal interest rates rise and the opportunity cost of holding money goes up, we would expect the quantity of money demanded to go down. We're going to want to put more of our resources in interest-bearing assets as the interest rate rises. And so money demand should fall. Be mindful of those things, by the way, because these other factors are going to cause the entire money demand schedule to shift around and therefore change the equilibrium value of money. Okay, any questions so far? We've talked about money supply and money demand. Let's now think about putting them together on the same set of axes so that we can look at the quantity theory from a supply and demand framework, all right? Okay, the only, I guess, non-standard feature of this model here is that we're going to have two vertical axes in our supply and demand model, okay? So in the standard way, we're going to graph the quantity of money on the horizontal axis here. That's the quantity of the good that we're modeling. And we're going to put the price of that good or the value of money on the vertical axis. That's going to be the left-hand side axis here. 1 divided by the price level, okay? The interaction of money supply and money demand will determine the value of money in equilibrium. But remember, most of the time, what policymakers and analysts are interested in is how money is related to the price level over time. That's why I've got this second vertical axis over here that measures not the value of money, but the price level. All right, so be really careful about that when you guys are drawing this on your exam. Hint, hint, okay? Yes, you will see a problem that looks at money demand and money supply in this framework, okay? Watch what happens here as the value of money goes up. Let's say from 1/4 to 1/2. The numbers on the left axis here are getting bigger in the standard way, but the numbers on the right axis are actually shrinking. Be very careful about that. So when you draw the value of money on the left axis and the price level on the right axis, the numbers on the left axis get bigger in the usual way, but the numbers on the right axis are actually getting smaller. And that's obvious. Why? Because the price level is just the reciprocal of the value of money, or vice versa, right? So as the price level falls, P is getting smaller, the value of money is getting bigger, okay? All right, now let's draw the supply curve. Notice that in this model, I've got the supply curve as perfectly vertical. In other words, it's fully inelastic. Why have I drawn it that way? Normally, the supply curves that we've dealt with in this class are upward sloping. If I were to do that here, then I would say as the value of money rises, the quantity of money supplied is going to increase. But why do I draw it in this kind of perfectly inelastic form? Fourth row? Exactly. We've assumed in this model that the money supply is a policy variable that can be set by the Fed, irrespective of what the price level is. So in this particular model, you've got to always draw the money supply curve as perfectly vertical or fully inelastic, okay? And so here we have a money supply curve where the quantity of money in circulation is, let's say, $1,000, okay? What does the demand for money look like? It's going to have its standard downward sloping shape to it, right? As the price level rises, and therefore the value of money declines, we're going to need more dollars in order to purchase a given quantity of goods and services. When the price of the candy bar goes from $2 to $3, we need that extra dollar in order to consume one single candy bar, right? And so the quantity of money demanded is going to increase. So the demand curve for money here has the standard downward slope like we've seen in other examples in this class. That is no different, okay? The only difference really is that the supply curve is perfectly vertical. Okay, just like any other market, the forces of supply and demand here should work in tandem to ensure that supply balances demand in equilibrium, all right? Where does that occur in the quantity theory of money? That occurs at point A on our graph here, where the value of money is in equilibrium is equal to 1/2, and therefore the general level of prices is equal to 2. All right. Let me ask you guys a couple of questions about this picture. What would happen if, let's say, the value of money was equal to, let's say, 3/4, and so the price level was 1 1/3. And what's happening in this particular model, this model of money demand and money supply? We have money supply exceeding money demand, right? And so there would be a surplus of money in the economy, okay? Now, what does the model suggest would happen then? If there's a surplus of money, the value of money should fall, and therefore the price level should rise in equilibrium. Now, does that make sense to you? If money supply exceeds money demand, does it make sense that the price level will rise? Hopefully that does make sense, right? Because if this is the situation we're in, where there's a surplus of money, then essentially what's happened here is that the Fed has created more money in the long run than people want to purchase the quantity of goods and services that they need. So you have too many dollars chasing too few goods and services. The value of that money will fall, and therefore the price level will rise. Too much money competing for too few goods tends to raise the price level in the long run. What if we're down here at a value of money of 1/4, in which the price level is 4? That's the exact opposite situation, where money demand exceeds money supply. So we have a shortage of money in our economy, right? The Fed has not created enough dollars to satisfy our demand for money. And as a result, the value of money is going to go up, which corresponds to a falling price level, right? When there's not enough dollars to purchase the quantity of goods and services that we need, the price level is going to tend to fall. The value of money is going to rise. The broader point I want to emphasize here is that what's happening in equilibrium. What this graph tells us is that the price level in the long run should adjust to balance the supply and demand for money. Therefore, if the money supply or money demand were to change, the price level should adjust to rebalance those two. Let's work through an exercise together here. I want to use this framework, this supply and demand framework, that is this quantity theory of money, to analyze the effects of a change in monetary policy. Okay? So here's the setup. Let's suppose that the Fed announces an open market purchase of bonds in order to increase the money supply. Okay? What is going to happen in the context of this model? So here we start at point A, where money supply is equal to intersects money demand. The Fed conducts an open market purchase of bonds to raise the money supply. Then what happens to the money supply schedule over here? It's going to, Wyatt? It's going to shift to the right. And let's just say that the money supply is doubled from 1,000 to 2,000, okay? What does the model predict is going to happen then? The money supply curve shifts to the right. And so now, at a value of money of 1/2, or at a price level of 2, we have a surplus of dollars, Wyatt, in the economy, right? We have more dollars than we have a demand for them. And so the value of money is going to fall in equilibrium, which would correspond to an increase in the price level. And you'll see here that the price level goes from 2 to 4. So a doubling of the money supply causes a doubling of the price level. So what the quantity theory of money says is, again, in the long run, this is not a business cycle model, but in the long run, what determines the price level in an economy is effectively the money supply curve. As money supply increases, the price level rises. What must be driving inflation then in the long run? How can we explain inflation? What could be the cause of the rising inflation that we saw in the US during, let's say, the 1970s? Why? Well, if an increase in the money supply causes the price level to go up, inflation is the growth rate of prices year over year. So this means that the central bank must have been expanding the money supply persistently over time, so that growth in the price level, that is inflation, can only be traced to growth in the supply of money over time, right? A one-time increase in the money supply causes the price level to rise by just one time. But a persistent growth in the price level over time must be caused by continuous increases or shifts in the money supply curve over time. Let me take a quick look at the adjustment process here, because I want to make sure everybody kind of understands how the economy gets from point A to point B in the long run, okay? So I'm going to go over the stuff that's on the next slide, but I'm going to reference this graph here. So you may want to look ahead on your own. Okay, so again, an increase in the money supply from 1,000 to 2,000 causes the economy to move in the long run from point A to point B, where the price level is doubled, okay? How exactly does this happen? Well, when the price level was 2 and the money supply was increased to 2,000 over here, you have this situation where there's a surplus of dollars in the economy, right? The money supply exceeds what people want in order to purchase goods and services with. People are going to try to get rid of that money in one of two ways. They're either going to spend it on actual goods and services, or perhaps they're going to save it or lend it to others through the financial system, okay? Ultimately, however, whoever borrows that money is going to turn around and purchase more goods and services, okay? And so the point here is that as the money supply increases, the demand, the aggregate demand for goods and services in our economy is going to go up as a result of that, because people are either going to buy more goods and services or lend those funds to others. But here's an important point. And again, this links back to stuff we talked about earlier in the semester. The economy's ability to supply goods and services is not affected by the money supply. Remember when we spent a couple of class periods talking about the solo growth model? One of the key pieces of that model was the production function, which shows that in the long run, the economy's supply of real goods and services was a function of just a couple of things. Factors of production, things like capital and labor, as well as the state of technology. Our economy's ability to supply goods and services in the long run doesn't really depend on what the money supply is. So think about this. If increases in the money supply raise the aggregate demand for goods and services, but the supply of goods and services is fixed in the long run by other factors like technology and resources, that's simply going to put upward pressure on the price level, just like we showed in this graph of the demand and supply for money. That's how the economy transitions from points A to points B, is that increases in money supply raise aggregate demand and therefore raise the prices of goods and services in the long run. Okay, you guys have any questions then about that? So that's really the first kind of perspective on the quantity theory of money, is looking at it from the angle of a supply and demand model for money. I'm sure there will be a question on your final exam that tests your understanding of that particular model. Let me go back now and kind of revisit the same type of question, but this time using the quantity equation. So we're going to do it a little bit mathematically here instead of graphically, okay? To do that, we need to define some of the concepts. Now, one that may be somewhat unfamiliar to you is this concept called the velocity of money. All right, that is defined as the rate at which money changes hands in the economy, okay? Velocity basically answers the following question. How many times per year does the average dollar in our economy swap hands between buyer and seller, okay? When you guys were in your high school or college physics class, you talked about velocity. Velocity is essentially the rate or the speed at which an object travels through time, right? So a car travels 60 miles an hour down the highway. A baseball player throws a baseball at 90 miles per hour. That's what we mean by velocity. In economics, velocity is a similar concept. It's the rate or speed at which the typical dollar in our economy is kind of traveling around the economy. That is swapping hands between buyer and seller, okay? Now, the other notation in the quantity equation is pretty straightforward, all right? We're gonna have nominal GDP, which is defined as the price level times real GDP, Y. Both of those variables we've seen before. The money supply we're gonna denote with a variable capital M, and velocity will denote with the variable V. The formula for the income velocity of money is given by the following. It's nominal income or nominal GDP divided by the money supply. All right, make sure you know this formula. The velocity of money is P times Y divided by M. Now let's work through an example here to try to make sense out of this particular formula, okay? Let's pretend for a moment that in our economy, we just produce and consume only one good, and those are going to be pizzas. So for the whole year in 2019, let's assume that our real GDP is 3,000 pizzas. That's how many are produced and consumed. Each of those pizzas cost 10 bucks, okay? And so what is nominal GDP in our economy? $10 times 3,000 pizzas is $30,000 worth of pizzas. That's the market value of this particular good. Let's further assume that the money supply in our economy is exactly equal to $10,000. So we literally have 10,000 $1 bills traveling around our pretend little economy here, okay? What must the velocity of money be equal to? It's simply nominal GDP, 30,000, divided by 10,000, giving us exactly 3. In other words, the average dollar in our economy was used in 3 transactions during the year 2019. Make sure you guys understand this interpretation. Think about this for a second. In order for $30,000 worth of pizzas to be sold in this year, when the supply of dollars in our economy is only 10,000, then that means each dollar must have swapped hands between buyer and seller an average of 3 times during 2019. That's how quickly money is circulating around the economy here. Now, what this shows you, hopefully, is that let's say that someone were to burn up half of the money supply, and so the money supply is now $5,000. In order for $5,000 to support $30,000 worth of pizza, the velocity of money would have to double to 6. Each dollar would have to change hands 6 times per year, okay? All right, let's do a quick exercise together to reinforce your understanding of this, all right? Let's say we've got a one good economy, corn. The economy has enough land, labor, and capital to produce 800 bushels of corn a year. The velocity of money is some constant, okay, which we're going to try to determine. The money supply is 2,000 and the price of corn is $5 per bushel. I want you guys to compute nominal GDP and velocity in 2019. Well, what's nominal GDP going to be equal to? Sean? Oh, the answer for velocity is 2. Yeah, so let's start with nominal GDP first. Nominal GDP is just going to be real GDP, 800 bushels of corn, times $5 per bushel, or $4,000, right? So Sean, how did you get the velocity of money here?
I just multiplied 5 times 800 and divided by 2,000.
There you go. You took nominal GDP of 4,000, divided it by the money supply, which we assumed was 2,000. And so the velocity of money in this easy little example is 2. Each dollar must exchange hands twice per year in order for $2,000 worth of money to support $4,000 worth of transactions in corn, okay? Any questions then about how to do that? Everybody kind of understand what the velocity of money means? Easy enough? Okay, now, what is the next step here? How do we obtain the so-called quantity equation from our velocity of money formula? V is equal to V is equal to P times Y divided by M. All we have to do is multiply both sides of that formula by the money supply, and we get that M times V is equal to P times Y. The money supply times the income velocity of money should be equal to nominal GDP. This is called the quantity equation. It's traditionally referred to the quantity equation because it shows us how the quantity of money in our economy is related to the nominal value of income overall. Now, how do we use the quantity equation? So again, what I want to try to do here is basically go through the same example that we did a few minutes ago using the supply and demand framework. That is, think about how an increase in the money supply changes the price level in the long run, but using the quantity equation instead of the supply and demand model for money, okay? In order to do that, however, in order to think about how a change in the money supply changes the price level through the quantity equation, we need to make some assumptions here about how the velocity of money behaves over time, right? What if the velocity of money changes a lot as you change the money supply? That can affect our predictions then about how M might affect P. All right, so really the sensible thing to do here is to actually go to the data to see if we can draw some conclusions about the money velocity in our economy. All right, so here's what I've done. From 1960 through 2019, I've got annual data on nominal GDP, that's the blue line, as well as data on the M2 money supply. Now I've transformed both of these series to be in an index level so that 1960 corresponds to 100 for both cases, all right? So the line really shows how the money supply and GDP have changed or have grown over time. The green line is the velocity of money. In other words, it's nominal GDP divided by the M2 money supply. Now, what do you see from that graph? The velocity of money, although it's not perfectly constant, has stayed pretty stable over time. So it might be a reasonable thing to assume then that changes in the money supply over time don't cause big changes in the velocity of money, that we can basically keep the velocity of money fixed. That way we can analyze directly how changes in the money supply affect the price level and inflation. And that's exactly what we're going to do, okay? So if you want to analyze through the quantity equation how changes in the money supply affect prices and how growth in the money supply affects inflation, step one is to assume that the velocity of money is fixed, is stable over time. Step two then is to recognize that if the velocity of money is fixed, then a change in the money supply should cause the same percentage change in the nominal value of GDP, right? In other words, if the money supply goes up by 10%, then nominal GDP should also go up by 10% because the velocity of money is fixed. Step three, you need to recognize that in the long run, a change in the money supply does not affect real GDP. Remember, I want to make sure you guys understand this point, is that real GDP, our economy's real output of goods and services, is determined by the state of technology and the amount of resources we have. That was the production function, which was a component of the Solow growth model, okay? Now, real GDP can certainly rise or fall over time, but what I'm trying to tell you is it's not really impacted by the size of the money supply. What this means then is that if the money supply were to change, those changes should be fully reflected then in changes in the price level, because the velocity of money is fixed and real GDP is determined by these other factors that aren't influenced by the money supply. The implication then here is that if the money supply grows rapidly over time, the price level should also grow rapidly over time. So the way we explain why countries have experienced unstable and rising inflation during some periods is because the money supply has also been unstable and has grown rapidly over those same periods. Again, a one-time increase in the money supply should cause a one-time increase in the price level, just like we saw in the demand and supply model. If we want to explain why inflation is running persistently high, let's say at 5%, and 8%, and 10%, and that can only be traced to persistent growth in the money supply year after year. Okay, let's work through a second example here to finish class today that picks up from the first example. And I want you guys to work on this one. So again, we're going to look at a one good economy where we produce corn and we have enough land, labor, and capital to produce 800 bushels, and velocity is constant. Now, if you recall from the previous problem, the money supply in 2019 was 2,000 and the price of corn was $5 a bushel. Here's what I want you guys to think about. Let's suppose that in 2020, the very next year, the Fed increases the money supply by 5%. So the money supply goes from 2,000 to 2,100. I want you guys to compute the values of nominal GDP and the price level for 2020, and then also the inflation rate between those 2 years. Part B, do the exact same exercise, but this time assume that there was some technological growth that caused real bushels of corn to increase to 824 in 2020. In other words, real GDP here rose by 3% at the same time that the money supply increased by 5%. What happens then to nominal GDP, the price level, and inflation as a result? Why don't you guys take about 3 or 4 or 5 minutes to work on that, and then we'll compare answers together, and then we'll call it a day. Just like you'll be expected to work a supply and demand model of money on your final exam, there will very likely be a question or two on there that requires you to analyze a problem using the quantity equation. This is a great example of one.
So for B, are we using 2,100 as the money supply?
Yes.
Is that there?
The only difference between A and B is there's been this simultaneous increase in Y. Anybody get an answer for part A yet? Nominal GDP, the price level, and inflation for 2020. Don't tell me. Ash. Sorry?
Speak up a little louder.
1.9 for inflation. So, okay, where do we start here? The quantity equation tells us that N times V is equal to P times Y, right? So for 2020, N times V should be 2100, that's the money supply, times velocity of 2, which is what we found in the previous exercise, right? Remember, velocity stays constant over time here. So if N times V is equal to 4200, then that means nominal GDP should be 4,200, right? So if nominal GDP is 4,200 and real GDP is 800, then that means the price level is $5.25. So a bushel of corn here should go from $5 in 2019 to 5.25 in 2020. And therefore the inflation rate would be the rate of change of the price level, which would be 5.25 minus 5/5 is 5%, which of course is the same as the percentage growth in the money supply. Ash, I'm not sure exactly where you went wrong there. You said 1.9, but the starting point here is the quantity equation. You know what M is, you know what V is, and so you should be able to get what nominal GDP is. It has to be equal to M times V. And once you get that, you can figure out what the price level is. And just like we saw in the graphical version of this same type of problem, where a doubling of the money supply caused the price level to double, here a 5% increase in the money supply causes the price level to go up by 5% as well. Sean, do you have a question?
Yeah, so is the inflation rate always the same increase?
No, that's a good question. So let's answer part B, and that should provide a final answer to this question. So in part B, the only thing that is different here is that there's been technological growth that causes the amount of corn that we actually produce to go up by 3% in 2020. Okay, so Sean, let's go through the same steps here. First, use our quantity equation. The price level should be equal to P times Y, which is the same as N times V, divided by GDP. So that's going to be 4,200, this time divided by 824, not 800. Which means the price level is $5.10. So that the inflation rate is 510 minus 5/5 is 2%. You see what's going on here? Here's the quantity equation. To answer your question, Sean, if there is a 5% growth in the money supply, that should cause a 5% growth in nominal GDP. Now, if real GDP doesn't change, the full 5% is going to be absorbed by the price level. But if real GDP rises by 3%, the other 2% is picked up in the price level, right? So that hopefully that answers your question there. When there is technological growth that causes output to grow over time, real output to grow over time, the price level is not going to rise by as much as the money supply does, right? So what this tells you, hopefully, is that in order for money growth to actually cause inflation, money growth has to exceed the growth rate of real output over time. If it exceeds the growth rate of real output, then whatever the difference between those two is going to be growth in the price level. So in our country, GDP tends to grow at between around 1.5% to 2% per year in the long run. So whatever money growth we have in excess of 2% is going to be attributed to inflation in the long run. Okay, you guys have any questions then about that one? All right, we will, so again, class will be canceled for Thursday. We will do a review question or two next Tuesday at the start of class, since it'll be a week since we've seen this, to kind of jog your memory. And then we will finish up by talking about the various social costs of inflation, okay? And we'll be done with that.